Everyone thought Oumuamua was past us, but it's back, and from the looks of it, it isn't stopping. After making its first appearance in 2017, it caused quite a stir, especially given that it had an unusual orbit. From what scientists gathered then, it came from some other galaxy. Now, there are theories that it could be coming straight for Earth this time. Some even claim that it is some sort of alien spaceship. But could it be? Let's find out. When you consider the vast world of astronomy, it is not the same as it was a few years ago. Not only that, but some of the things that happen in outer space are beyond our basic understanding. Imagine a space rock roughly the size of a football field just speeding across space and acting unlike anything else that has ever been seen. Even with all that, we can tell that this isn't your typical space fragment just cruising through. Space scientists are trying to understand it, but even they are having difficulty doing that. On the other hand, onlookers are reacting with a mixture of wonder and fear. This object is working against all the rules known to scientists, moving at a speed that makes no sense and is completely off course. And did we mention that it also appeared from nowhere? Through observing the object, it seems that it has its own independent thought. And just when you think you are starting to understand how it's working, it accelerates and changes course, throwing you into a continuous loop of having to understand it. There is no logical way of explaining its behavior. But why is this strange interplanetary object behaving like this? Oumuamua is a comet that was discovered in 2017. Upon its discovery, both scientists and the general public were captivated by its name. This was the first ever extrasolar visitor that didn't have the characteristic luminous coma and dust tail that other comets often do. It also had an unusual form, something that seemed like a cigar from one angle and a pancake from the other. It was also too tiny to be anything other than an asteroid. When it comes to objects that have been hurled into interstellar space, they may come from a variety of things. Some originate from other planetary systems and are propelled there by the gravitational pull of gas giant planets that are constantly ravaging their neighborhood. They can also be driven by massive collisions, which would end up tearing protoplanets into pieces. In the case of Oumuamua, it is the first to shed light on the nature of the existence of other solar planetary systems because it is the earliest known interstellar object in our solar system. It was given its name from a Hawaiian origin. Oumuamua is Hawaiian for a messenger from afar arriving first. That was a pretty convenient name. Even as the first interstellar object in our solar system, it doesn't seem to be stopping for anything. According to scientists, it will likely make a direct impact in 2 weeks. But what led them to this conclusion? Keep watching to find out. When Oumuamua first came into our planetary system, it was discovered by a telescope in Hawaii known as Pan-STARRS. Apart from the fact that this was something completely new in our planetary system, something else stood out about Oumuamua, and this was its form. At first glance, the object seemed to be about 10 times longer than it was wide, so from a certain angle, it seemed like a cylinder. When the measurements were initially taken, the comet measured 6.1. However, after years of continuously monitoring Oumuamua as it moves along our planetary system, astronomers have eventually managed to adjust these measurements. From the measurements that they have given, it seems as though it is some sort of pancake shape. As much as there is such an object, have astronomers ever found another one in our solar system? Even though this is not the same material as Oumuamua, it has the same shape. This was discovered in the Kuiper belt, which is beyond Neptune. The structure that had the same shape as Oumuamua was, in fact, a minor planet called Arrokoth. This minor planet was discovered after NASA's New Horizons spacecraft flew past it on New Year's Day 2019. The measurements of Oumuamua's shape and dimensions were mainly based on its light curve. This graph shows how the object's brightness changed over time as it orbited through space. Whenever the astronomers were seeing its broader side, Oumuamua seemed to be brighter. In addition, Oumuamua was also pretty small, given that it only has a measurement of 377 feet in length, 364 feet in width, and 62 feet in thickness. The measurements for thickness were based on its albedo of 0.1. This simply means that it reflected about 10% of the sunlight that fell on it, which is not as strange when it comes to cometary nuclei. However, everything about Oumuamua keeps getting interesting. After its discovery, astronomers naturally became more curious about it. They simply wanted to learn all they could about it, and one of the ways to do this was to point more and more telescopes at it. After a few years of studying Oumuamua, one of the most interesting things they learned was that it had already completed a full orbit around the Sun. In fact, they came to learn that it was leaving the solar system. Another thing that astronomers came to learn about Oumuamua was that it was very elongated and flat on its ends. They came to this deduction after noticing that it had uneven brightness changes, which would occur every 12 hours. However, there is one thing that made it clear to all the astronomers that this was indeed a comet and not an asteroid. Unlike asteroids, comets are known to have a higher acceleration, even though it is small. This is especially the case when they are moving away from the Sun. As comets are moving towards the Sun, they start expelling dust and other gaseous comas made of water and other substances. All this comes from their surfaces. Most of the time, they are seen to have one tail that is visible as dust. This one is left behind by the comet. On the other hand, there is a second tail that seems to be pointing away from the Sun, along with some inertial push. This second tail is usually composed of vapor and particles that have been pushed away by the light pressure from the Sun. Apart from this, entrapped organic molecules and carbon monoxide are also some of the substances that may be released from the comet. Oumuamua is proving to be a very interesting comet, defying some laws as we know them. However, even through all this, it still remains quite unstoppable. So does that still mean that it will still have a direct impact in 2 weeks? Keep watching to find out. As Oumuamua was going around the solar system, it experienced a gravitational deflection around the Sun. This was caused by a number of reasons. The first one is because of its extremely tiny size. This made it possible to be affected by the little push that was produced when the hydrogen gas spewed from the ice. Because of this simple factor, this comet has been set apart from all the other comets in our solar system, especially those that have been extremely examined. Each comet has its own distant origin, and when you consider that in the solar system, most comets make periodic approaches to the Sun as they are orbiting the solar system, a comet's ejection of water and other molecules, which is mainly caused by the solar heating, gives it a luminous coma. Not only that, but in most cases, the comets also end up having gas and dust tails. We have already seen that comets are different from asteroids, and since they are lighter, they are easily deviated from their elliptical orbits when they receive even a little kick from the released gases. This is something very familiar with the objects in our solar system, such as asteroids and planets. Oumuamua was a comet unlike any other that astronomers had seen. It didn't have the same composition as other comets in our solar system, and it was moving in some sort of strange manner. However, even with this complexity, astronomers did everything they could to understand as much as they could about the comet. One of the things they speculated widely about was the composition and force propelling the comet outward. This was motivated more by the fact that the comet was detected without a coma or tail. Furthermore, it was too small to collect enough energy to release a significant amount of water and too far from the Sun. There are many theories as to what this is. There are those who claim that it is the outgassing of hydrogen gas by an iceberg of hydrogen, which can basically be considered a large fluffy snowflake that has been pushed by light pressure from the Sun. Others claim that it is a light sail that was created by an alien civilization. On the other hand, there are those who claim that it is a spaceship under its own power. Comets are an integral part of the solar system. They are basically ice objects that lingered from the solar system's birth, which was about 4.5 billion years ago. And because of these comets, scientists are able to gain some insight into the circumstances surrounding that time. These comets have also provided some insight into some planets and stars. For those stars that are encircled by disks and could one day host planets, they can be inferred from the behavior of interstellar comets. Just like we said before, comets are important in knowing the history of a solar system. They mainly provide a window into the makeup of the solar system, especially when it was in its protoplanetary disk stage of evolution. By studying them, scientists can gain a deeper insight into the early stages of when the solar system was coming to be, especially when our solar system was just small and less massive. We have been talking about comets and how they are important to our solar system, but how did they come to be? Comets are actually ejected from faraway planetary systems. This is mostly the result of gravitational interactions with other objects in the system. This was the same thing that happened with our solar systems in the past. From time to time, there are rogue comets that make their way into our solar system. These rogue comets give us a great chance to learn about planet formation in other systems, especially when they periodically visit our solar system. Over the years, scientists have been keeping an eye on Oumuamua, wanting to learn everything about the comet. With this, they have gone on to learn so much. Apart from one thing, the scientists have not managed to pinpoint the exact location of Oumuamua's stellar system. This is one of the greatest mysteries surrounding the comet, and it will remain like this for quite some time now. Nonetheless, researchers managed to trace Oumuamua as it returned to its original route. By doing this, they ended up learning information that would spark the interest of everyone who was following the status of the comet. This is information that could potentially change the way we see the comet. Scientists came to learn that about 1 million years ago, the comet had passed close to 4 stars. Of these 4 stars that it had passed through, the red dwarf HIP 3757 was the one that it had close contact with. This can only mean one of 2 things: either this is where Oumuamua originated from, or the comet has been moving around space for a lot longer. One thing that is common between all solar systems' planetary bodies, including asteroids and comets, is that they all follow a tight orbit around the Sun. But if this is the case, then there is something wrong with Oumuamua's trajectory. According to a NASA animation, it shows that Oumuamua's trajectory was simply hyperbolic. This means that when it was approaching the Sun, it did so at such a high speed, and because of this high speed, its route could only be minimally bent by the Sun's gravity instead of being caught in a looming circle. But what does this mean? Does it mean that it will orbit the Sun at a different rate? Well, the answer is simply no. What this simply means is that Oumuamua could keep on going towards the exit door of the solar system. Not only that, but it will do so at a velocity of about 16.36% close as 23 million miles to our star, which in space means that it was actually closer than ever. Scientists and astronomers kept observing the comet just to see its behavior. Now that it wasn't using the regular route, during this observation on October 19, 2017, the University of Hawaii astronomer Robert Werrick discovered something pretty interesting. He revealed that Oumuamua had made a few appearances in the observations made by the Asteroid Hunting Panoramic Survey Telescope and Rapid Response System. At the time of being spotted by the telescope, Oumuamua was about 21 million miles from Earth, and according to its trajectory, it was going to be as close as 15 million miles from Earth, which is pretty close. Since this discovery was made, the extraterrestrial guest has now been slowly moving away from our solar system. NASA has made sure to detail everything about this comet, including the speeds. From their records, they detailed how Oumuamua was propelled to a speed of about 54.2 m per second by a gravity boost from the Sun. Considering the fact that Oumuamua was small and had a rapid ephemeral motion, it could only be observed for a very short time, and during this observation, the Hubble Space Telescope was the only one that could follow it for the longest period of time. Data was being collected from various points, among them being 2 of the world's largest optical telescopes, the Very Large Telescope in Chile and the Gemini South Telescope. When merged, the data that was collected from these 3 stations was enough to produce the finest photos of Oumuamua. Actually, any data collected from here could generally reveal any star, including one that was as tiny as a speck. Oumuamua has come very close to Earth, and it has already been taken off course by the Sun. But where is Oumuamua right now? Is it still coming for Earth, or is it still unstoppable? Let's keep going through the facts to find answers. At the moment, Oumuamua has already departed from Neptune's orbit, and it is now en route to Pegasus. The comet has already managed to slip beyond the reach of any observatory and is now moving through the Kuiper Belt, which is normally a ring of frozen objects. The Kuiper Belt is also found close to the solar system's periphery. Considering its current trajectory and how it is moving, it is clear that Oumuamua has no intention of ever coming to Earth again. Now, whatever Oumuamua was is a matter of conjecture. We can already tell that it was an object that was thrown out of Oumuamua's orbit by the gravitational waves of roving gas giants. This can be deduced from the fact that it came from an extrasolar planetary system. Before the discovery of Oumuamua, astronomers had a high expectation that interstellar objects were comet-like. This ended up being the case for two, i.e. Borisov. There have been quite a lot of assumptions and expectations about Oumuamua ever since it was first discovered. One such assumption that astronomers made was that Oumuamua was just a dead comet, whose volatiles or gases that had low boiling points, such as water, evaporated over billions of years. This probably happened when it was still in its original system or when it got close to other stars. This is probably why it never really had a cometary tail, which is unusual for a comet. However, even with all that, the Hubble Space Telescope confirmed that Oumuamua's outward route from the Sun only signified that the comet moved purely from non-gravitational acceleration. This is something common when it comes to comets. Whenever they are moving through space, they mostly get their acceleration and momentum from releasing water vapor and dust in a tail. On the other hand, Oumuamua did not emit any of the volatile substances or water that are mostly seen in comets. As a result of this, scientists now have even more questions. This is a comet that did not really exhibit some of the common comet-like abilities. However, they were very sure that it was a comet as a way to try and explain the nature of Oumuamua. Scientists and astronomers alike started coming up with various theories as to why it is the way it is. In the end, there were two main theories that really stood out, and they were convinced that it was one of them. The first one uses Oumuamua as a block of nitrogen ice. This theory came from Arizona State University's Alan Jackson and Stephen Desch. They reasoned that areas like Sputnik Planitia were basically made of frozen nitrogen lakes. This was spotted for the first time by New Horizons in 2015 as it was swooping past Pluto. Since this is clearly not a strange phenomenon, Jackson and Desch argued that Oumuamua could be a piece of nitrogen ice that was blasted off a Pluto-like body through a massive impact. As for the extra push that Oumuamua needed, it could have come from the outgassing nitrogen, which is sublimated by the sun's radiation. However, even if this were the case, nitrogen is known to give comets a more reflective albedo, which records at about 0.64. This can only mean that Oumuamua had to be smaller than initially anticipated for it to appear so pale. Jackson and Desch went ahead to do some calculations, and they found that the dimensions of Oumuamua would have been about 148 by 144 by 25 feet. However, this was only if it was constructed from nitrogen ice.